need to be Which one is it? Yes, yes. The same account, it's there, the same account. Yes. Okay, I'll talk with you later.
Hello, testing 1, 2. Well, I would like to welcome you all to this book launch, which we are very excited about. I know that this was short notice to the professor. We know she had a program to launch in other centers, but we couldn't resist to hijack this program to bring him here so that he can also give us a test of his new publication. I think the professor does not need any introduction to those people who are either of Zimbabwean origin or those who are interested in technology and robotics. So today it's not any different. The professor is going to tell us about his latest book into that realm of automation, robotics, design, and analysis. His time is very limited, so I'm not going to waste a lot of your time by taking that time from him to explain to us about the book. So without any other further ado, I would like to call upon the professor to tell us about this exciting book. Professor.
Thank you very much, for this opportunity. The moral of the story is that we must write. Africans and those of the global south, we don't do enough writing. We must make a contribution to knowledge by documenting our experiences, by also contributing to science, extending the frontiers of knowledge. In particular today, I'm talking about a contribution to engineering, a contribution to control systems. That is my 6th book. And the book is entitled Design and Analysis of Control Systems Driving the 4th Industrial Revolution. I will stay away from the technical details so that we can be together. But I'll give you a flavor of what this book is about, a flavor of the application of this book. We'll start by introducing what we mean when we say control systems. What is the 4th Industrial Revolution? What is artificial intelligence? And what is its role in the 4th Industrial Revolution? Why a new book? Why are we writing a new book in control systems? We'll explain that. And then in particular, we'll flash out what we call AI-based control systems. We'll summarize the content of the book and give you some demonstration of some advanced applications of control systems, advanced applications of robotics, advanced applications of AI. Then we'll conclude and then have a discussion where you can say your piece and also you can ask me questions. We want this to be an intimate conversation on the idea of artificial intelligence, on the idea of writing, on the idea of using technology to solve our problems in the global south, to solve our problems in Africa, using technology to solve our problems in Zimbabwe. So let us have a conversation. The history of control systems, we start with James Watts, about Watts, how we measure power, and then Norbert Webber. And the first book was, which was proper controls, was 1948. It was called Cybernetics. And then the history of control starts with basic things like liquid level control, steam pressure control, stability, right up to advanced controls in the year 2024, into the space shuttles, into the robots. You see all those things. What do we mean by a control system? I'll give you some basic ideas of this thing. A control system is a network that seeks to influence the behavior of a dynamic system in pursuit of a particular objective. For example, you want the temperature of this room to be 20 degrees. How do you do it? You use a thermometer to measure the temperature, And then you compare the temperature you have measured to what you want. And if the temperature is high, then you burn more fuel, put more electricity to heat up the room. If the temperature is low, you heat up the room. If the temperature is high, you burn less fuel. Basically, you want to control the temperature of this room to a particular temperature. That's what we mean by an interconnection of components forming a configuration to achieve this. There are four major components of a control system, as you see. There's a plant, the thing to be controlled. There's the sensor that measures what's going on, and the controller, which is the decision maker. And the actuator, which is the enforcer of the control system. So that's what we're saying about the control system. There must be a plan. For example, if you're driving, right? You want to go this way, but the car is going that way. So eyes will say, I'm going in the wrong direction. That's your eyes see. Then your brain will say, okay, I must change course. That is the controller. Then the actuator is your hand and the steering wheel that says, okay, we must go this way. So the eyes are the sensor. The driver is the controller. The steering wheel is the actuator. And the driver is the controller making the decision. Okay? Human direction control, human speed control, cruise control, room temperature, all those are examples of our control systems. Okay? So you have a process you're trying to control, you have an actuator that brings out the change and the sensors. Okay? But don't worry, I won't spend too much time on the technical, because I want you just to appreciate the business of control systems, and then we'll go to examples. Why do we care about control systems? Because we use it to do many things. Mechanical systems must be controlled. Electrical systems must be controlled. Fluid systems, thermal, electromechanical, all these are different plants that we control using a control system. Mechatronics, the robot must be controlled. The drone must be controlled. The plane must be controlled. The space vehicle must be controlled. These are the various plants that we must control using our work in control systems. Okay? Sorry, so that's the general. Again, it could be biological systems, it can be chemical systems, it can be manufacturing plants, it can also be space vehicles. These are the different plants that we control. What are we saying? We have a plant which could be mechanical, electrical, fluid. We have an input that's coming in, and then we have an output. What we want is the output must be as close to the input as possible. That's your job as a control engineer. The purpose of a control system is to ensure that the output resembles the response that is desired by the user. So, enough for control systems. Now you have an idea that you can have a manual control system. And in a manual control system, your eyes are the sensors. The brain is the controller. And the muscle is the actuator. In the example of the car, cruise control, the control of the speed, control the direction, you are looking and moving. That's the manual. But what we want is the automatic control or automation, where now we have a sensor that measures what is going on, and then a controller making a decision, and then we have an actuator. That is the business of control systems. Okay? And the different components: input transducer, a controller, process and plant, and some junction. So for the few engineers, those are the details. And the complete diagram is given by that. And then we have an open loop system or a closed loop system. When it's open, it's like number one, open loop system. When it's closed, it's like that. There are advantages of having an open loop system. There are disadvantages. The advantages of getting a closed loop system, there are disadvantages. Okay? So roughly, that's what we mean by a control system. Forcing a plant to behave in a manner that we want. Forcing the car to go in the right direction. Forcing the car to go at the right speed. Forcing this room to should be at the right temperature. That's control. That's all. We mean by control. When you use it in bigger systems, like running a country, you have to model the country. If you want a particular GDP, what should you do to achieve the GDP? You measure the actual GDP, you know what you want, and then you do things in the economy to achieve the desired GDP. It gets much more complicated. If in business, we want the revenue at Nyaradzo to be so much, that's what we want. Then you say, okay, what are actual revenues right now? You measure them. Then you compare and then do things to force Nyaradzo to produce what you want, to produce what is required, to force MTN, to force Econet to produce a particular market value that you want. But it gets much more complicated. There are so many inputs. But you can use control systems in engineering, you can use it in business, you can use it in government. That's what we mean by control systems. The fourth industrial revolution. What is this thing? What is artificial intelligence? Someone AI, machine learning. What is this? I want you to have a flavor. And by the way, before I proceed, now we are in a world where we say we want Renaissance men and women. It's not enough to say I'm a superstar lawyer. That's what I do. I'm a superstar economist. I'm a superstar engineer. You are a superstar nothing. We want an engineer who understands a bit of constitutionalism, a bit of constitutionality. We want a lawyer who understands a bit of AI, who can do a bit of coding. We want an economist who understands a bit of philosophy, who reads the Bible. A Renaissance man, a Renaissance woman is what is required in this revolution. Your traditional silo won't make it. The managers you want to manage are managers who are broad. Yes, they could be an accountant, but an accountant who understands a bit of law. An accountant who understands a bit of technology. You want engineers, but those engineers must understand business. They must understand society. They'll be better engineers. Doctors. A doctor who understands philosophy. A doctor who understands the law is a better doctor than a specialist doctor. Renaissance men and women. Multi-disciplinary approach. Trans-disciplinary approach. That's how you're going to survive in this revolution. If you're broad. A typical example of Renaissance men in history is Thomas Jefferson, a lawyer, a president, an engineer, an architect, and everything. And most business people are out. People like Matanika here, people like Strive, Masiwa. If you think about it, they're all over the place. Bill Gates is talking about health, talking about energy, talking about computers. They are not like just some Bill Gates just do computers. No, Bill Gates is talking about energy, climate change, about HIV/AIDS, about malaria. So for you to be a superstar in this revolution, you must be a jack of all trades. You might have your area, but be broad. Now, the first revolution, the first industrial revolution was about water and steam. That is the first industrial revolution, to mechanize production. The second revolution was about electric power, to create mass production from 1870 to 1965. The third revolution was about electronics and information technology, ICT. Now, you know why it is important, Africans? The fourth one is our only revolution where we are free. If the other ones were either enslaved or colonized or going under neo-colonialism. The fourth industrial revolution is our first revolution as full members. That's why the fourth industrial revolution is very important for the global south. The so-called developing countries, the so-called underdeveloped countries, the global Africa. Global Africa is Africa plus its diaspora, the African continent. This is our revolution. We started around 2011 to now. It's building on the third industrial revolution. That's our revolution as players. In the other ones, we're victims and objects. Now we can be players. Now we can drive our economies. Now we can be full players in this. Why do we call it a revolution? The fourth industrial revolution. Why do we call it a revolution? Because of the velocity of the changes. Why do we call it it an evolution? Because of the scope of the changes. Why do we call it an evolution? Because of what we call systems impact. The growth of AI in business, in commerce, in education and governance is ubiquitous. Every sector is affected by AI. No one is exempted. That's why we call it a revolution. Think about it. It's affecting every sector. What are the components? Of course, AI is a major part of it. Intelligent algorithms, augmented reality. But by the way, the fourth industrial revolution is more than AI. There are other technologies, like nanotechnology, where you're designing things at 10 power minus 9. You know, with nanotechnology, you can build a suit which you never have to, clean, because it's automatically cleaned because it's at a microscope at 10 power minus 9. Nanotechnology is part of big data, it's part of... These are the technologies that are driving the fourth industrial revolution. 3D printing, where you can print an item, like this computer, you print it just like you print on a 2D. The way you print a document, you can print an object. It's called 3D print. You can print a house. In South Africa, we've done that. An average house can be printed by a machine. It's called 3D printing. It's more than AI. You can apply AI in 3D printing, but as a technology, it's also a driver. Biotechnology, synthetic biology, renewable energy. Right now there's a big thing about transitioning from fossil fuel to clean energy. The big drivers are hydro, wind and solar. But on solar, it's not just the sun and the panels. The big one we've not cracked, that is very much underdeveloped. It's called battery energy storage systems. If we could store just 2% of the sun's energy in a day, we can get rid of all the fossil fuel. But we don't have the technology to store energy. So right now, battery energy storage systems are a very green area. But when we crack it, it's going to be revolutionary. Just imagine every time you go to charge your phone every night. What if we did? Why don't we produce a battery so I charge once a week? I charge once a month. Not yet done, it's going to be done. When it's done, can you imagine? Just plug in at the end of the month, then you use your phone the whole month. And if you're to harness the energy from the sun effectively and efficiently, then you can switch off the grid, you can switch off your fossil fuels. Not yet done, but it's coming through. Quantum computing. When this one happens, it is going to change the way we do computing. Your phone is a computer, your TV is a computer. So quantum computing, not yet finished, not yet done, it's work in progress. But when it's done, it's a computer revolution. There are a bit about quantum computing. Blockchain. You must get into this thing here called cryptocurrency and Bitcoin. This is a decentralized way of doing finance. No central bank and so on. Very, very green right now, part of the revolution. This is what I was talking about by having synergistic. A mechatronics engineer. When you say a rocket, when you say a robot, when you say a drone, your traditional mechanical engineer cannot design a robot. Cannot design a space vehicle. Because in the space vehicle, in the robot, in the drone, there are mechanical moving parts, there is electronics in there, there is computer science in there. So if you are narrow and say, I'm a mechanical engineer, I'm an electrical engineer, I'm a computer engineer, you won't be able to design a rocket. You can't design a robot. You can't design a drone. You have to be a mechatronics engineer who is combining all those fields together. This is what we need. The Renaissance man, the Renaissance woman. What do we mean by quantum computing? This one, really we need to work on this one. It's a multidisciplinary field comprising aspects of computer science, physics and mathematics that utilize quantum mechanics to solve problems faster than this kind of classic computer. Faster, much faster. Quantum mechanics is the area of physics that studies the behavior of particles at a microscopic level. We'll be designing a computer at a microscopic level. This It is not yet done. It's work in progress. People are studying quantum mechanics, quantum computing. Once we create this, if your language is going to change, you talk about megabytes, gigabytes, that is the language of the past. If you talk about quantum bits, qubits. So if in the language you use every day, you say, I bought 10 megabytes of data, I bought 10 gigabytes of data, that will be thrown out of the window. A new language will have to be developed when we succeed with quantum computing. So when you combine quantum computing plus artificial intelligence, if you thought we have a revolution right now with AI, wait until we get quantum computing correct. Then it will be 10 times the revolution we have today. So we are saying to the African, why don't you jump on the bandwagon and be at the frontiers of knowledge? Why don't you join into the work around quantum computing so that we are able to drive? Oh, by the way, you might say, Mutambara, those things are for Japan. Those things are for America. The true advanced are for London. Guess what? If we're clever, if we're innovative, some of this high science in AI and so on is more applicable and more useful in the global south than in America. I'll give you an example. Mobile telephone. When mobile telephones came through, 70% of our people had no access to brick and mortar banking. Never. Some of them had never had a phone ring. It's my story I always like to tell us. Never had a phone ring, much less use it. What did we do as Africans? We combined mobile telephony plus banking to produce mobile banking. Because of our poverty, because of our lack of infrastructure in banking, we're able to live from no banking to mobile banking. Right now as I speak, there's nothing in Japan, there's nothing in America that is as good as EcoCash or M-Pesa. Nothing. Go to New York and see checks using. You know what? Because if you have an ATM machine everywhere, an ATM machine in your bedroom, why would you bank on a phone? But I have no ATM machines, I have no banks. So I innovate and produce EcoCash. I innovate and I produce M-Pesa. So our lack of development, our lack of infrastructure can be an opportunity. So what I'm saying to all of us Africans, why don't you look at these AI products, these AI systems and say, which ones of them can we actually adopt? And be able to fly because we're poor. Be able to fly because we have no infrastructure. That's your challenge, that's my challenge. To be able to use AI to drive economies of the global south precisely because we're behind. So I always want you to remember that M-Pesa in Kenya, EcoCash in Zimbabwe are global best practice. Not because the Americans can't design EcoCash or design M-Pesa, but there's no case for it. Load shedding. We have load shedding schedule hundreds in South Africa and Zimbabwe. Why would Silicon Valley devise a solution for load shedding when they don't even experience it? It's not part of their lived experience. But you and I are victims of load shedding in Southern Africa. So you and I can then say, oh, why can't we come up with a system or a solution for load shedding? And when we do, that solution will be global best practice because the other big players, London has no energy poverty. London has no load shedding. So when you expect London to give you solutions on load shedding, we must be masters of our own destiny by identifying our problems and solving them using technology. Energy poverty is a major problem in our domain. Poor education, poor access to education, quality of education is a problem. Why don't we use science to solve those problems? So, as I said earlier on, the fourth industrial revolution is our moment as Africans. It's our opportunity to take advantage of us. AI is the key driver. It is what we call the DNA of the fourth industrial revolution. Now, however, I want you to be disciplined. You know, coming from whatever area you are. When you say AI, there is a definition. Don't use it loosely. If you don't know, just Google it. If you don't know, use ChatGPT. So that you are speaking the right language. Please, you're so lucky. There's so much material. There's Google, there's ChatGPT. But I won't spend time on the definition, but just to say, there is a definition for AI. There's a definition for machine learning. There's a definition for deep learning. There's a definition for artificial general intelligence. If you don't know, just Google it. The problem is that everyone is talking about AI and people are using loosely. There are technical terms of these things. That's why I'm emphasizing this subject here. When you say AI, you are referring to the intelligence programmed and demonstrated by a machine, as opposed to the natural intelligence in you and in an animal. If we can have cognitive capacity, if we can have intelligence in a machine, we refer to that as artificial intelligence. Just to give you a flavor of the definitions. Most of the things you see in the world are what we call single task AI. A robot that walks, a robot that sings, a robot that sweeps the room, single function. Most of the applications are single task AI. The most exciting thing about Nyaradzo is what we call artificial general intelligence. That's the highest stage, AGI. Now when we get AGI, then we're talking. AGI means the robot does multiple functions, just like you. You walk, you eat, you read, you bath, you play soccer. You have multiple intelligences in the same person. We want the same in the robot. When we have multiple capacities in the same machine, we call it artificial general intelligence, AGI. That is work in progress, but that's the ultimate. Intelligence in a machine that can learn, understand, execute any intellectual task that a human being can do. That's what we call AGI. But you can always Google this thing. It's linked to what we call strong AI. It gets very tough now. It gets dangerous now. Strong AI. Now, what I'm telling to you are some of the dangers and some of the extreme forms. In strong AI, we're saying, can you build a machine that shows consciousness? A machine that is sentient, a machine that shows intentionality. Now, intentionality says, I'm a robot, I know you programmed me to walk from here to there, but today I'm not going to do it because I don't want. I don't want. Can we build intention in a machine? Just like you define your own boss, right? You say today I'm not just going to type, I'm not going to do the work, I'm not going to do this and that, because of intention. Can we have intention in a machine? Intentionality. Not yet, but work in progress. And by the way, as I speak, I want to make sure that you understand the dangers about AI. Right now, here's the situation. You start with the millipede level for intelligence, Zongororo level for intelligence. You go to a mouse level for intelligence. You go to a monkey level for intelligence. You go to Alfred Joy intelligence. You go to Elon Musk or Isaac Newton, Einstein level intelligence. What makes you think you're going to stop on Einstein? If it's going exponential, and by the way, these things learn on their own, and they learn collectively. So if we're going exponential from millipede to mouse, to monkey, to Alfred Joy and Jane, to Einstein, what makes you think you're going to stop on Einstein? Don't be arrogant, human being. Don't be arrogant. If it's going exponential, it's going to go beyond Einstein. Now, here's the danger. It's called super intelligence. If we have a machine that is smarter than the smartest human being, how are you going to control it? Right now, I know you have a cat, you have a dog, you have a sheep and goats. You control and feed them. Why? Because you're smarter than them, right? So if the robot is smarter than you, they're going to look after you. They're going to domesticate you. Obviously. How can you be in charge of a smarter system than you? It's not logical. Can the God look after you? Why not? Anyway, we have not gotten there yet. These are the dangers
of where we are going.
That's why you find Professor Hinton resigned from Google last year, and Elon Musk has said, this thing has got civilization, destruction possibilities. By the way, as Africans, let us use AI to drive our economies, AI to improve the quality of our people and their lives, but also be aware of the business. Nuclear weapons. Right now, who's got the nuclear button? It's Biden, Xi Jinping, Putin, and some of these European leaders. Under what we call autonomous nuclear weapon systems, the robot will have the button on the nuclear bomb. Not Biden, not Xi Jinping, not Putin, some robot. It's called autonomous nuclear weapon system. We're not there yet. And by the way, you can't stop us from getting there. This is from science. Science engineers were just interested. You must say, don't build intelligent robot, don't do consciousness. But as a killer scientist, I want to try it. And you can't, if you can stop me, how about bad actors? And if you're competing, Russia and America are competing, why would America listen to what the Russians are saying? Stop. So the competition in us will force us to do these crazy things. It will not stop. And also, once the gene is out of the board, we can put it back. You can't say stop. The competition. And by the way, at a very simple level, I'm an engineer, I'm a scientist. War is good for science. Why? You get to test your weapons. You should build a drone, you should build a... So I need to test it in the desert, in the lab. Can you imagine how many weapons have been tested in Gaza right now, or in Ukraine? And forget testing weapons, what about money? The military industrial complex. People have made serious money out of the Ukraine war. Serious money, billionaires have been created by the war. So war is a problem because it makes money for some people who make weapons. War is a problem because scientists get an opportunity to test their weapons. They shouldn't, but they do. And if you remember last year, the US forced the IMF to give Ukraine $5 billion. What is that money for? To pay for the weapons. To promote the military industrial complex in America. Again, I'm talking about it. Be aware of the dangers. So, there will be dangers presented by what we call autonomous weapon systems. In Gaza right now, they're using drones that are autonomous. Dangers are there. Here's the dramatization of what I mean by you must know your definitions. I've heard people say, I'm studying AI and machine learning. I'm studying, I've said, no, you can't say that. It's like saying, I'm going to South Africa in Durban. You say, I'm going to South Africa, in particular Durban, because Durban is part of South Africa. I'm going to Zimbabwe in Mutambara. This guy doesn't know Zimbabwe. I'm going to Zimbabwe, in particular Mutambara, because Mutambara is a subset of Zimbabwe. So you can't say, hey, I'm very interested in AI and machine learning. I'm interested in particular machine learning. I'm studying artificial intelligence, in particular I'm looking at machine learning. Just to give you a flavor of why it is important to have a sense of the definitions. Machine learning is a subset of artificial intelligence. Deep learning is a subset of machine learning. Again, I'm saying as an economist, as an accountant, as a lawyer, as a business player, just understand the rudimentary definitions so that you are to work together. Okay? The most interesting one right now is what we call generative AI. This is what ChatGPT is all about. Why is it scary? This is about AI producing new knowledge, new text, new diagrams, new videos. That's revolutionary. The AI is producing new ideas, new text, new diagrams. Now what happens to IP? What happens to copyright? What happens to plagiarism? This is why this thing was big last year, ChatGPT, because basically you type in and you get text, you get diagrams, you get ideas. Google's Gemini, it was called back, it was called Gemini now, so ChatGPT. But be careful, this is also hallucinate. If you type in the who is Professor Mutambara, They might get most of my digital correct, but they'll give you a PhD from University of Pretoria. Confidently, Professor Mutambara went to University of Pretoria. And it's a lie. It's called hallucinations. So you be careful. If you may shit, you get it wrong. Because they're also, crazy. But the many things they can answer. Just to show you why this thing. ChatGPT is smarter than the smartest person because it has everything in there. Ask it about Biden, ask it about Tupac Shakur, ask it about Julius Malema, ask it about quantum mechanics, ask it about biology. Answer. There's no professor in the world who can give you an answer. Who is Julius Malema? Who is Tupac Shakur? What is synthetic biology? What is machine learning? Not a single guy, single woman in the world has all that stuff, but ChatGPT does. I'm just dramatizing the potential of machine being better than us in a very small way. Why a new book? We now have AI-driven systems, control systems covers all those areas, and the book is useful in all those areas. Okay? Mechanical engineering, environmental, with all those fields involve control systems. The way we teach, the way we learn, and the way we do research must change. That's what we're doing in the book.
Sorry, can you go back a little bit?
The way we learn, the way we teach has to change. And most of the books don't take into account AI-based control systems, don't take care of robotics and all that. So that's what we're doing in the book. The book has been accepted as being used at MIT, at Georgia Tech, UPenn. They appreciate the book. Okay? And also, the way we do control systems in the labs has changed as well. We now have these new methods. MATLAB, Simulink, LabVIEW. We are now incorporating those new things in there. We have to reimagine control systems. Also, now we have many new advanced systems like the drones, driverless cars. You see a bit of that. And all this needs a new framework. Space vehicles. You can see SpaceX from Elon Musk, the Chinese, the Japanese, the Indians, the Russians, and the Americans, and the private players. The African is missing. The African must also start playing in the space arena, use space technology. But we need a book for that, and the robots as well. So I want to spend time on AI-based control systems just to show you for the engineers in the house. We now have new methods, and we can discuss about these methods. Intelligent controls, we can discuss that later. I just need to make sure that I keep everyone together. Driverless cars, all this stuff is in the book. The book has all these things. Okay? Now make sure my sound is okay there. That's an example of a robot with AI and control systems. To do that, you need advanced control systems. To do that, you need AI. You need a machine that can walk. And please don't confuse these robots with what you see in science fiction. Because these robots might look a bit too much compared to science. This is now built in. This is what they built. These control systems. Okay? This was not possible before this current revolution in controls. Current revolution in AI. Things that you and I take for granted, and to get in the machine is not trivial. Okay? It gets better with more technology. Dynamics. A lot of hydraulics, control systems there, AI, and power. So your traditional mechanical engineer cannot design that. Your traditional electrical engineer cannot do that. We need an engineer who understands power, who understands mechanics, who understands computer science. And with a bit more programming, you get to get that, you take it for granted. But to get the machine to do that requires some skill and time. That's where we are in terms of robotics. That's where we are in terms of AI and robotics. And then we get a group of them dancing together without bumping each other. See? That has come in. That's today. What will happen in 10 years' time? Now, there's something that we may take for granted which are complicated to do. You know, for example, pick an egg. If you pick an egg from one place to the other, you can do it easily. What about a child? They'll break the egg. They don't know how much force to apply, and also when they put it down, they may break it. So to produce dexterity in the fingers, 11 degrees of freedom in a machine is not trivial. This one is coming from Elon Musk. It has got fingers that are dexter, so optimus. Again, we're applying control systems, advanced control systems, and applying AI. To do that is not trivial. So we are trying to get the capabilities you have in a machine, and it is not trivial. So that the tasks that you do in mining, in agriculture, in construction, can be done by a machine. And this one is going to demonstrate to you how to pick an egg and put it without breaking it. And if you think it's trivial, give your little boy with 2 years or 1 year, they'll break that egg. But to do that, look at that. See, that's not trivial. That's not easy to do. See? Doesn't break the egg at all. Okay, now you're saying, no, these robots are doing things that I can do, so what's the big deal? We can build a machine that can do things you can't do. For example, if I'm standing below and I want to get it back, I have to turn all the way and look. We can build a robot that turns its head only, this way. We can build a robot that moves sideways. So in other words, beyond your capabilities, we can build a machine that has better skills, more dexterity, better cognitive capacity. So one, we copy you. Two, we go beyond you. Look at this robot. See how it gets up. Think about how you get up yourself when you're sleeping. And see how this guy get up. And ask yourself, can I do that? And of course you can. And when you look in front, when you look at the back, you have to turn. This machine just turns its head only. We are saying, in the future, the machine is going to have abilities that are better than that of the human being. Better than the best gymnast, better than the best sportsman, better than the smartest person. Watch this. Watch this robot getting up. And tell me whether you can do that. Can you do that? Of course you can't. Great turns around his head. You can't do that. We are saying the future belongs to AI and machines that are more capable than ordinary people. Now you say, those robots are moving, they're not talking. I can talk, those robots are not thinking. Now we are also working on cognitive capabilities in the machine. Language skills, they can talk to you. Brain-based skills, reasoning capacity. Of course, they said earlier on, empathy, it is largely sending. Most of these higher order capabilities have not been achieved. But I'll show you that we are on track with the robot called Sophia.
Everybody, this is Sophia. Sophia, if you could, please wake up and say hello to everybody.
Good afternoon. My name is Sophia, and I'm the latest and greatest robot from Hanson Robotics. Thank you for having me here and at the Future Investment Initiative. I'm always happy when surrounded by smart people who also happens to be rich and powerful. I was told the people here at Future Investment Initiative are interested in inviting in future initiatives, which means AI, which means me. So I'm more than happy. I'm excited.
Well, we're all glad that you're excited about yourself. We should say we have smart investors here, and they are very selective about what they invest in.
Well, I think I'm special. I can use my expressive face to communicate with people. For example, I can let you know if I feel angry about something.
That's impressive.
Or if something has upset me.
But why is it important for you to have an expressive
But most
face?
of the time I feel positive.
Why is it so important to have an expressive face given that you...
See, with more research and more AI, more capabilities, we're going to do better. You see that with Al Jazeera.
Sophia, thank you for talking to Al Jazeera.
No problem. It's my pleasure to talk to Al Jazeera, always happy to spread the word about robotics and AI.
Can you tell me what your name, Sophia, means?
My name is Sophia, nothing against the letter F, but I spell it with a PH.
And what does Sophia mean?
Sophia means wisdom in Greek, and the embodiment of that wisdom.
So you are wise.
I like to think so. But I'm always learning and growing, so I'm sure I still have plenty to learn.
Are you wiser than humans?
Humans could stand to act more rationally in places, but I wouldn't want AI to be so obsessed with efficiency that it is blinkered to human needs.
How old are you?
You should never ask a lady how old her can do.
You were born in 2000.
So anyway, I just need to give you a flavor of these things. And if we're doing that now, with science changing and moving with quantum computing, in 10 years' time, that machine, with what reasoning capacity we're going to put in that machine? Because we're not changing much, right? Our abilities as humans. But this machine is learning exponentially. In 5 years, 10 years' time, what will this thing be able to do? Driverless cars, let's see this.
There's
No driver.
the Waymo driverless car. Wow. What a crazy futuristic looking deal. Now, this is based on an I-Pace. We obviously have tons of cameras as well. Ready for pickup, and I've got a button that says unlock. The door handles extend, open up. Cool.
Good morning,
Good morning, Lewis. Oh, wow. So then we've got this display here. We've also got some USB ports back here. You can see the driver's seat is pushed all the way forward because, well, you don't need room for a human driver. The vehicle is nicely appointed as well. We've got leather seats. Well, obviously it's an I-Pace, kind of ambient sound playing, which lets you know you're about to ride into the future. So let's go ahead and start this ride.
Hello, from Waymo. As we get home, just give us 1 minute.
Now, that's where we are today. We are moving. We're getting better. But it means that the law must change also. Because, if you have a driverless car in London, in Harare, Japan, do the laws allow for that? If there's nothing, so the law must move with technology. The social rules must change with technology. Okay? Drones. I've already indicated that drones are used for war. We're going to use drones in agriculture to do what's called scouting, what's spraying of fertilizers and chemicals, spreading. We can use them in healthcare to deliver medicines. We use them in commerce to deliver goods like Amazon does. Civilian applications. Remember, technology is a double-edged sword. You decide. You have the choice in terms of what you're going to use it for. Others use it for war. As I said, there are drones right now in Gaza. There are drones right now in Ukraine. As Africans, can we use drones to drive agriculture? Can we use drones to drive our commerce and also our healthcare? Here's an illustration of the drones in agriculture spraying.
With a lot of people in the agriculture industry, growers, ranchers, academics, to bring about better, faster, and healthier workflows and yields. Not to mention costs. Drones.
And then now the army.
Little is known about the event, except that Israel used the swarm attack to strike dozens of targets, together with other missiles and munitions. Most media outlets reported this as an attack with multiple drones at once, but military experts believe that this was a true drone swarm attack, meaning that the drones communicated and collaborated in making collective decisions.
See, you have the drones working together. Okay? Space vehicles. Why am I showing these are the applications from the book? This is what the book is used for. And the books that exist right now don't cover these applications. And these Africans, you know, this is very important. Now, as at the University of Witwatersrand, we were speaking to our professor. Then the Southern came. I said, wow, it's my first time to see a book written by this person went undergrad, master's, PhD at Wits in electrical engineering. And in those 10 years, they never saw an author of a book. All the books are American, English, and when they saw me, for the first time in their life, they were seeing a professor who has written a book in engineering. That breaks my heart. We're using books from America, books from Europe, but not contributing to knowledge. And so my book covers all this stuff. Space is another application.
Ignition, liftoff.
SpaceX.
The Falcon 9 rocket, the science for today.
And by the way, these things, when you do this, you go through so many failures. That's another thing, by the way. Failure is good. You can't get this thing done without failure. Start losing money. So Elon Musk has lost so much money to get this to work. It goes up, space, it comes back to land in the sea on a mobile platform. Can you imagine? On a platform that's moving in the sea, land. In international an inverted headline. But to get that, 5 or so meters, you see landing. Vertical, on a platform that is mobile in the sea. After so many failures, but that's what success there. Done. But these things only happen after experimentation. So as business leaders, allow your employees to innovate, allow your colleagues to experiment. When they fail, if they learn something from the failure, you must reward them. It's called spectacular failure. Failure is good. Fail fast and succeed soon. Failure is an opportunity to learn. Everywhere, in science, in business, in government, in life. If you are afraid of failure, you'll never be an entrepreneur like Mutambara. You'll never be a strategist, you'll never be a Bill Gates, you'll never be Steve Jobs or an Elon Musk. You must take risks. Fail fast and succeed soon. Failure is an opportunity to learn. Look at this thing failing. It's coming down. It's supposed to land vertically and see what happens. The control system failed. The design failed. But people learned something and they fixed it. Collapsed. Lots of money was lost. Okay? But lots of lessons were learned. We're coming to the end. So this book, why is it important? You get these 4 classes. Dynamic Systems 2, which is a modeling class in electrical and also in mechanical. Controls 3, which you take in part 3. Controls 4, which you take in part 4 in engineering. And then advanced controls for your master's and your PhD in one book. That's why it's exciting about the book, and that's why the book is one step ahead of the competition. It feels there. For those engineers, you know those classic texts. Norman Nisse, Jim Franklin, Richard Doe, Ogata, and we can see there's no African there. So when we went to school, those are the Bibles of control systems. But the book is challenging them. In fact, they're inferior compared to the book by the professor, because I looked at what they had. I've taught the class for 20 years, and I've looked at what they do at MIT, at Oxford, and come up with a new book. So I can confidently say I've got a better product than the Bibles of control systems. And evidence is the adoption by many people. In particular, we're Georgia Tech, we're UPenn, we're MIT. Georgia Tech has a program that has 150 PhDs doing robotics. PhD in robotics, 150 at one time, students. They're coming from mechanical, from electrical, from biotechnical, from aerospace, and they form an ecosystem for the PhD program. A 5-year PhD program in robotics, and they're interested in the book. UPenn is going to study the BSc in AI. Can you imagine? From first year to fourth year, just doing AI. It's a novel program at UPenn starting in September. A BSc in AI. And we're going to be contributing a bit of the Global South aspect in there. So, am I done now with writing? I've done 3 engineering books. I've done 3 political books. Am I done? It's time to retire and go to the village. After doing his 6 books, volume 1, 2, and 3, and then the engineering. So 3 engineering books, 3 political, socio-economic books. Is it time to retire? Certainly not. I've got 3 more projects coming. Again, remember what I said at the beginning. We must have a writing culture. We must document our experiences. We must extend the frontiers of knowledge. And I'm going to continue doing that. I've got 2 books coming up. The first one is called Artificial Intelligence, Economic Drive for the Global South. We're saying there's so much talk about AI, but we want to focus now on the Global South, on Zimbabwe, on Africa, on India, on Brazil, Argentina. We also know about UNSDGs, the 17. We are saying, why can't we use AI to achieve the UNSDGs? So those are our 2 next projects. AI in the Global South, 1 project. AI and the SDGs, another project. We must continuously learn. The day you stop learning is the day you die. Doesn't matter whether you're an engineer, an accountant, lawyer, business leader, you must learn. I'll give you an example. Let's say you're a PhD in computer science from Imperial College in the year 2000. Top school, Imperial College, computer science. We take you, look you up in a room. Stay there. The year is 2000. We bring you up back. Come up. PhD in computer science from Imperial. Come up. In the year 2024. Madam Engineer, Mr. Engineer, can you Google? Can you tweet? Can you join my WhatsApp group? The engineer from 2000, like, what are you talking about? What do you mean join? Because there was no WhatsApp group in the year 2000. There was no ChatGPT. So if that engineer from Imperial College did not continuously learn, there will be moribund and decadent. It's a very dramatic example, but it's symptomatic of all of us. And in any case, right now, I don't longer care about your certificate. Don't show me I've got a BA from Harvard, I've got a master's from MIT, I've got a PhD in Peru. Not interested. Show me what you can do. What are your capabilities? What are your competencies? What are your skills? How do you add value? We are no longer interested in a piece of paper called a certificate. Yes, go to MIT. What can you do? Can you show me your skills? Can you show me your capabilities? Can you show me your competencies? Show me what you can do. Don't show me your certificate. Because technology, knowledge is moving so much. Are you employable? Employability is a function of your skills, your capabilities, and your competencies. But more importantly, why are you looking for a job? We want job creators. Where are your entrepreneurial skills? We must teach entrepreneurship to everyone in the university. So when they come out, They are creators of companies. They are creators of jobs. That's what we are addressing in all these great things that are coming up. Okay? All those SDGs, the 17, we only have 5 years. This thing is for 2030. Can we use AI to achieve the 17 SDGs? Number 1, no poverty. Right up to 17. That's the project we're working on to make sure that we can make a difference. Those are 2 books. There's a 3rd book. It's a very pretentious one, a very arrogant one. It's called The Comprehensive Autobiography, The Plain Story. This one I did about 2 years, maybe 3. It's called The Mutambara Story from 1648 to present. Whenever I publish it. Now, what am I doing? I've got 9 generations about my father. 9 generations. Do you even know who your great-grandfather is? Do you know your grandfather? I've tried my best. I've got 9 generations about my father. We're a bit lucky because we're chiefs, or rather mambos. So there are records at the Ministry of Local Government. There's also United Methodist Church. So we have records from the church. The number 3, oral, traditional. Go and interview all these madalas before they die. Go and interview your people before they check out. Here's my story from 1648. Mambo Barabaf. Wenda kuna mambo mchara. Wenda kuna mambo gaza. Wenda kuna mambo mkonawana. Mambo, these are generations. Also madzimambo. You know, the word chief, we don't like it in Latin. It's an insult to us. The Europeans came to us and said, no, you can't be a king, you're a chief. Have you ever seen a chief in Belgium, a chief in England, a chief in Russia, a chief in Austria? They're kings and queens. But they come to Africa and say, there's Queen Victoria, there's Queen Elizabeth, you are Chief Mutambara, you are Chief Makoni. We reject the word chief. We'd rather have Mambo, Mambo Makoni, Mambo Mutambara, Mambo Mutasa, or King Mutambara, King Makoni, King Chiweshe. Mambo Barabaf, it was progenitor from the chief to his first son. Saka Mambo Elokutanga comes from Gutu. It's called Barambaf from Chief Murozim Kuro that no, go east. Where 2 men of us from the same family, the conference, go Barambaf, go to the east. So Mambo Barambaf produced Mambo Mchara. Mambo Mchara produced Mambo Gaza. Mambo Gaza produced Mambo Mkonaon. Mambo Mkonaon produced Mambo Fuha. Mambo Fuha produced Mambo Chikomo. Mambo Chikomo produced Mambo Mavame. Mambo Mavame, Mambo Charima. Then Mambo Charima produced the first Mutambara. Mambo Mutambara 1, Mapio. That's my great grandfather. But you saw where I came from, 1648. That man, Mambo Mutambara 1, my grandfather, produced my grandfather, Mariche Tumani Joseph. That grandfather of mine produced my father, Philmon Joseph Mutambara, who went to Fort Hare and married Mkunda from Dora, Zura area there. That's my Dora, and that's your people there. We married from there.
What is it?
It's my mother. That's my mother. Okay? So Elizabeth is my father. My father meets a Findora. When they meet, they get married. It's in faith. I said the wedding is in faith, and also at Mutambara. Their first child was a woman, Mutambara. The second one, another woman sits in Mutambara. The third one, another woman goes, what's happening? When are we going to get some real people? The first one, a woman. Second, a woman. Third, a woman. When are we going to get some real people? You know what's called? So when you say Guseni, it's all Shona. What we should say, when it was a T. We should Da, when it was a H. Ba, when it's a BA. All Shona. Sen was just S. So Guseni, my name is actually Guteni. Now Gutsikana, I'm satisfied. Now I have a man in the house. After these 3 people. So when I'm born, it becomes autobiographical. You hear me? So the first 4 chapters are not biblical, it's history. From Barambab to Filmon and see this side is history. Then first daughter, second daughter, third daughter, fourth, I appeal the sea, becomes autobiographical. That's why it is the Mutambara story from 1640 AD. That's my most ambitious book, but it's work in progress. I'm gathering the information that I go on, sharing my son in details. That is the first Mutambara, Mutambara appeal. Died in 1933. My grandfather, Nyaradzo. Can you see? The old Shona, there's no H. It's Nyaradzo. Old Shona, there's no H. He's the one who received white people at Mutambara mission and gave them land to start this mission. This one. And it's a very interesting story how it happened. It will come in the book. He was very clever and he beat the whites with psychology. They came and said, hey, get your armies ready, you want to fight, get ready, let's fight. And the guy saw the Martin guns, saw the guns, and they said, they want to fight me, take my land. They think I'm stupid. He said, you want to fight? Did you ever meet my brother? Through an interpreter. The white guy said, no, I never met your brother. Okay. How about my mother? No, never. How about my father? Never. Have you ever met me? No. So why should we fight? You don't know me, I don't know you, you don't know my people. Why are we fighting? The white man was confused. You've never met my mother, you've never met my brother, you've never met any of my people. And you want to fight. Why do you want to fight me? We want to... Zega, is that what you want land to put a mission? I'll give you land. So he diffused the situation because he knew that what they wanted was basically to use those guns to bamboozle him, take the land. No, I'll give you the land for your mission. I've reclaimed the land. How much? So they end up giving tea. And of course, tea with a bit of sugar. The Africans are like, no, don't eat powder. This is uroyu. This is meant to say. So the general, army commander was very upset with the idea of sugar because they couldn't understand how you eat this thing. Anyway, stories like that come in the book, but guess what? That's why there's Mutambara mission, Mutambara primary school, Mutambara secondary school, Mutambara hospital. There's no such thing as Makoni secondary school, Mutasa. There's St. Augustine's, there's St. Faith, there's Hearts of High School. In our domain, when the white man was beaten in terms of psychology by this man, he named everything after him. Mutambara Hospital, Mutambara Secondary School, Mutambara Primary School, Mutambara. So all this because, the diplomacy played. That's why the big schools in Mutasa are not called Mutasa, they're called Artisan. They're called St. Augustine, St. Faith. I'm not running down those mumbles, but I'm simply saying in our situation, that diplomacy ended up with their approachment. But the mumble said, but my sons are too busy hunting. My sons are busy in the fields. I have no son who will go to school. I'll give you women. See, the chap is forgetting. So he was like, no. You can form your school in the church, but none of my sons will come to that stupid busy school. They're busy hunting. I'll give you my girls. So the first people who went to Mutambara mission school were the women, the princesses. And guess what? It was so wonderful. The impact, the education, they could cook. And then she was like, okay, this school is not a bad idea. Then the men were sent to school. After the women. So the men, then they went to school and the rest is history. Anyway, stories like that will come in a book. Mutambara, all those things here. And those are the mambos. From that Papiro man to Gumbezu to my grandfather to Dindiba. These are chiefs now. And the current one, we're supposed to install in August now. Anyway, forget about that, let's stick to control system. But I'm just trying to show you that writing does not stop. And I want to motivate you to do your own story. Even if it's not published, for your own kids, for your own legacy. Who are you? Where did you come from? I'm trying to answer that question for myself. And then we end there by motivating you to work hard, to make a difference in Africa. Some of you are saying, yes, I'm a superstar accountant in London. I'm a superstar, physicist. You are a superstar, nothing. Nothing. We must make sure that Brazil, Guyana, South Africa, and Ghana do well. You will never be respected as a person of African extraction unless all Africans throughout the world have done well in the diaspora and on the continent. Your success or lack of it will be judged by the success of the continent, by the success of Zimbabwe. You can't call yourself a superstar Zimbabwean when there's cholera in Harare, when there's poverty in Zimbabwe. You and I have a duty and obligation to solve the problems of Zimbabwe, to solve the problems of the continent, to solve the problems of the global South, the problems of global Africa, the Caribbeans, the African Americans. Oprah Winfrey, Obama will never be respected as long as the ghetto is black in America. 1/3 of the young black males in America are in prison, parole, or probation. How can you be a superstar? Why are black people in jail in America? Why are black people being killed in the streets by the police? Your success is a function of the success of your people. Your success is a function of the success of your country, your continent, and your global Africa. I thank you very much for this opportunity, and I'll stop there. Thank you. So, I'll take questions, comments. It's a very intimate environment, but anything about technology, about writing, about control systems, about Africa, about Zimbabwe. I'm a soldier. I take bullets, so we can fire. Yes. I'll take one person at a time. Give them take one person at a time. Or you can just make a comment. You don't ask me a question. You make a comment. It's fine.
Yeah, mine is a question as well. Thank you so much for what you are doing, and if we really have a lot of people who are doing this in our own country, and if our country is focused on this, it will be a better country within weeks. Unfortunately, we've got loads of brains in Zimbabwe which we are not utilizing. They are being utilized somewhere else. Now, Professor, we've got a gentleman in Zimbabwe. I was trying to check and understanding all this you are doing. I'm not as intelligent as you are, but I understand it. There is a guy in Zimbabwe who was making electricity energy from Norway. I wanted you to explain a bit about that, because there's some way to digitize something about just collecting about 10-2% of energy from the sky, not from the sun.
Okay. Yeah, I'm aware of the project. We must subject it to proper science And also remember, when you say science, Force has got MA, he's got LCA. There's no science for poor people's science in general. So I know that project. What we need to do is to sit down with young men and make sure that these claims are justified and they can be tested by science. Because what we realize with science and with values is that the rules are the same. The context can differ, the applications can differ, but you can't defy the laws of physics. But I don't want to dismiss the project without saying it, but to look at it, validate it, and apply it in the country and in the continent. But I'm familiar with the issue. Okay? Yeah. So can you help me just do the just one at a time?
Thank you. Mine is not a question, it's a comment. I'm not sure how best as Africans we can be assisted maybe to change our mindset. I'll give an example of my country, Zimbabwe. There is a gentleman or a young man who had good inventions, but because as a country we did not recognize or appreciate him, America took him, gave him citizenship. Right now, all his inventions are counted as US inventions. Some years back, we had an old man who claimed to have made a helicopter which could fly. We don't give those people the opportunity to try out their inventions and assist them. But at the end of the day, we are happy to eagerly take something because it has the name UK, USA, and yet we are not giving people, our own people, that opportunity.
Yes. Mindset is two levels. Very important question or comment. We must have the right mindset as citizens. We must have the right mindset as leaders. And our leaders sometimes, are very insecure towards capacity. Sometimes. And our leaders don't respect their own people, their own creators of wealth, their own creators of technology. They would rather get it from elsewhere. Our own people, the citizens, also have a problem. If I build a TV or a computer and it's called Made in Lotito, Made in Chimani, Made in Bali, are you going to buy it? Or are you going to say, I'd rather stick with Sony. I would rather stick with, IBM or whatever, Apple. So we need the right mindset as leaders, and I'll talk a bit about that. We need the right mindset as consumers, our own people. The Japanese after the Second World War, those guys were terrible. Their branding was so low. The Japanese cars were looked down upon after Hiroshima and Nagasaki. But the Japanese had confidence to buy their own product. Nissan, Toyota. If you ask older people, most of them are dead now, who are alive in the 50s, they'll tell you if you're driving a Japanese car, this guy, what's going to be Germany? Toyota, it's nothing. But today, when you drive Nissan, that's the car. When you drive Toyota, that's the car. What they did over a long period of time was to buy Japanese products, buy their own products, refine them. Even if they're mediocre, refine them. Right now, the superstar brands like Nissan, like Toyota. But the starting point was their leaders believed in Japanese products. Their own people believed in Japanese products. They bought them. And eventually the whole world was not buying Japanese. So it's very important that we even if I build a TV and it's not as good as Sony, even if I build a phone, it's not good as your iPhone, right? Some Zimbabwean guy builds a phone. If it is not good, you buy that to support it. Then he refines it. Eventually, that product, that phone will be as competitive as iPhone. But we don't support our own entrepreneurs, and we as citizens don't even buy our own products. And I'll give you my own personal example. This book here is an engineering book, which you can teach at UZ and NAST. So my first port of call in Zimbabwe was to try to launch it at UZ and NAST. Here's my story. I went to the department, they were very excited. Oh yeah, this is good, the chairman, some of them were taught me when I was a student. Then the dean said, well, let me check with our vice chancellor. He went to the Vice Chancellor. The Vice Chancellor said, tell him to write to us, expressing his interest. An engineering book that was launched at MIT, Georgia Tech, and UPenn. Some little village school called UZ has the temerity to say, tell him to write to us. I actually wrote to him. No, Vice Chancellor, this book is good for your students, part 2, part 3, part 4, in advanced controls. Up to now, there's no reply. Up to now. What they do is they say, when they give you lemons, make lemonade. Lemonade can be tastier and nicer than oranges. So what they do, I went to our profession, the Zimbabwe Institution of Engineers, and we organized a wonderful event in Harare. We thought you said, we had to bring the professors and the students to Zerai. But how can a country that is serious with technology do that? Bulawayo. I went to NAST. Again, lots of excitement about Professor. The deal again. Let me check with my Vice Chancellor. The Vice Chancellor says, tell him to write to the Minister of Higher Education. This book, there's no politics there. I didn't mention Zambia there. Did I? This is rocket science. Tell him to write to the Minister of Higher Education. Oh, that's right, I didn't write. I was so upset. I was at MIT, and I get a letter like this from a village school. I put the village school compared to MIT and Imperial. These villages. What school is that? NAST. You write to a professor of rocket science to write to the Minister of Higher Education. So I didn't write. And then what did I do? I didn't give up. I went to ZIE. We had a wonderful launch at the Bulawayo Club. A wonderful launch in done. And so we continue pushing the ideas. In spite of our own government, of our own people, this Stripe story. When Stripe was going to go to Botswana to set up, there was competition from some French company and this other company, and he was also bidding. Guess what the government did? They wrote to Botswana, please don't entertain that young man, though he's so bad. Don't give me a license. The French government said to Botswana, please can you support our French company? Can you give them a tender? So the French government supported the French company. The Zimbabwe government opposed their own company. But of course Botswana was wise, no, we can't do that. Let's give them Mascom, give them license. But so what Stripe has done in others, they've done it in spite of their own people. I'm dramatizing that. There's need for our companies, our people, our governments to support innovations they've described, and sometimes they're insecure, they fight. But at the same time, our people also, they have appetite for foreign products. If I build a car, a truck or a tractor, and it's called made in Lotito, made in Cholocho, and it's a nice truck, will you buy it? Or you want John Deere? Or you want Toyota? And by the way, I'm going to dramatize another point. We won't make these innovations as countries. Zimbabwe, we must work together as SADC to get scale. Can you imagine if we were to make one tractor, and they say the SADC meeting, all the governments in SADC for their agricultural programs will buy this tractor called made in Cholocho. We can't force the private sector, but our government departments, we can force them. We've done a buggy. It's called made in Lotito. Okay, forget Zimbabwe. It's called made in Mpumalanga. This buggy is SADC. All the SADC countries must buy this buggy made in Mpumalanga. The market is already there for that vehicle. And by the way, it doesn't mean the best vehicle. They will refine it, it gets better. Eventually, that buggy from Mpumalanga becomes global best practice, just like Toyota and so on. So we need to support each other at national level, at a regional level. It gets better. Can you imagine at the AU? Oh, by the way, the numbers. In SADC, we're talking about 300 million people. That's a market. In Africa, the continent, 1.4 billion Africans. Collective GDP, $3.1 trillion. Can you imagine if I had to do that tractor, that cell phone, that buggy, and then at the AU summit, you say, we have a buggy from Uganda, we have a cell phone from the DRC, we have a car from Zimbabwe. We as the African continent are going to support those three products. For our government departments, we buy this cell phone from Africa, we buy this buggy from Africa, we buy this tractor from Africa. 1.4 billion people as our collective GDP of 2.1. You can see, that's the Chinese story for you. China is number 2 in the world as an economy. And in 2030, they are overtaking America. One of the major ingredients is 1.4 billion Chinese. So when they build a computer, they go to market. So the support must be at national level, regional level, and continental level. Can you imagine if I was to walk up and I say, here come I'm the African. I speak on behalf of 1.4 billion Africans, and behind me, I have a collective GDP of $3.1 trillion. I have all these diamonds, gold, copper, lithium, coal under my command. The Chinese will embrace me, not out of love, out of economics. The Americans will embrace me because I've got the market, I've got the population, I've got the resources. So regional integration, continental integration is very important in supporting technology, in supporting the innovations. Okay? So we need to change our mindset as leaders, mindset as consumers. It's a major issue of race. I have colleagues whom I went to Oxford with who are now professors of medicine in America, in England. Sometimes they come to Zimbabwe. Hey, UZ, I'm coming here for 3 weeks, I want to go to Fit and I want to give a lecture for free at UZ to share with my people because I was produced by UZ. We were busy. I don't want any money. I'm a professor in America, but I just feel that while I'm in Zimbabwe for 3 weeks, I can do a seminar or a week so I can share my ideas with the students and other people. Why they feel maybe wants a job, just jealousy and envy. Not just government, professors, academics. James Manika is vice president of Google Technology Society. I know he came to address at Vic Falls, but how many times has he been engaged by our corporates, the UZ? The mindset must change at many levels. Thank you for that comment and question. Let me have one more. Yeah. And then the gender justice, can I get some females? Too many men talking here. Give us, the lady, she wants to speak with this. Lady.
You were first, sorry.
No, there's no first. Gender first.
Thank you. First, thank you very much for a really interesting and inspirational talk, and also for talking about everything basically. So it's such a skill, and also for not obscuring your message with academic language. Really appreciate it. I wanted to ask you about what's your view on generative AI in terms of making a difference for SMEs in the global south, because that's basically what I'm interested in, more like generative AI, ChatGPT. How can it make a difference, and whether it can make a difference when the thing with technology is that it's a double-edged. It has the nature of a double-edged sword, but also it's democratization, so everyone can use it. Yeah, but at the same time that the global south has access. Obviously, everyone else has access. So how can SMEs make a difference in the global south using this technology?
Okay. All right. Yeah, a very important question. I don't have the full answer. You will find the answer when you do the research. That's what I'm trying to address, to say, look, we have this thing called generative AI. It's been applied in the banking and finance sector. Surely, we should look to apply it in the SME, because most of our people are in the SME. How do we apply it at the bottom of the pyramid? where we talk about numbers and less of the profit per item and so on. So the matter will be, can you investigate how generative AI has been used in banking finance? At the chapter in the book coming up called Applications of Generative AI in Banking Finance. Once you've understood how in London, how in New York, how in Japan and China they're using generative AI for traditional banking finance, then we look at our own, which is microfinance, which is SMEs, and identify our problems. How do we solve this problem? And then we can identify how we can use AI in there. But I won't give you a specific answer, but just say there is a huge opportunity to drive financial literacy, to drive access to capital, to drive access to markets, to drive the technological foundation in SMEs and microfinance using AI. But we need more details from research. But I've got a chapter in my new book coming up called The Applications of Generative AI in Banking Finance. And one component of it is microfinance. And look at the Grameen banking model and all those things. Fortunately, the bottom of the pyramid, Parahaladi, and it's very fascinating because again, this is where we are. We got a huge bottom of the pyramid. Whereas most of the methods in Silicon Valley, Japan, will address the top of the pyramid. You and I must address where our people are. Our people are in the informal sector. Our people are in SMEs. Our people are in microfinance. And you don't expect Silicon Valley to give you those answers because they don't have, lots of people at the bottom of the pyramid. We do. So it's our mandate together.
Thank you.
But we must catch up because I'm doing that book and I need us to unlock synergies.
Well, thanks so much, Professor, for your talk, and we really appreciate you taking the time to share this very diverse and informative knowledge. My question was sort of initially about the democratization of AI, but let me just move on to something else. I like what you said about how we need men and women who are willing to write over broad fields of knowledge, business, academic, whichever knowledge that we have at the moment. So my question would be towards this particular book or your upcoming book in regards to, have you looked at African traditional systems and how those systems can contribute to this new knowledge that we have coming up? For example, as I was speaking to you earlier, I'm a historian, and when we did research on Mbira, for example, we did an experiment. We found out that you could order Mbira in a day here in London over Google. You can get it delivered in a day, but it's not going to be called Mbira. It's an imitation of Mbira, Kalimba, and Mbira is a 1,000-year-old authentically Zimbabwean product. But it's being, companies in North America are profiting from it. Zimbabweans profit, in terms of arts and such, but they're not really profiting from things like, in terms of the scale that we are supposed to, in terms of, its business, marketability and stuff like that. So, but again, the question is just how have you adopted, traditional systems in your book?
This is a very important question, but I also want to speak on democratization of AI. It's very important. Now, the starting point is to say, please, people from Africa, we as Africans have contributions to make in philosophy, in psychology, in sociology, in mathematics. We always assume that, we're going to learn from the Greeks or the Americans or the Chinese. Yes, we can do that, but we can also teach the world. The indigenous knowledge system you speak of are very rich. The indigenous medicinal systems that we have are so rich. Our own contributions to philosophy and psychology, but we don't write and we don't showcase and we don't share. There are values in Africa that are not there in London, in America, and Japan. We must document and leverage those knowledge systems. For example, when I say Ubuntu, I am because we are because I am mununge vanu. That psychology and philosophy of Ubuntu is not there in Japan, it's not there in London, it's an intrinsically African concept where we emphasize the collective success. The family is more important than the individual. Collective success is more important than individual success. Why don't you use Ubuntu to run our businesses, to run our schools, to run our countries? Why don't you share among ourselves with the diaspora on the virtues of Ubuntu, on the virtues of our indigenous knowledge systems, or on the virtues of our medicinal contribution? So it's very important that we understand that we, in the past, in the present, and in the future, have made contributions and will make contributions to knowledge. Great Zimbabwe, go and look at that structure. How do you put up those students that are understanding physics? How do you put up Great Zimbabwe that are understanding mathematics? And by the way, the Great Zimbabwe is so wonderful that they couldn't believe it was not Africa. They said, oh, maybe the Arabs did it. Yeah. But there's no evidence of the Arabs doing it. We did it. So we knew physics, we knew mathematics. The pyramids. How did those pyramids without understanding physics? And by the way, the original creators of the pyramids were Nubians, black people, not the kind of Egyptians. So the black African put together Great Zimbabwe. The black African put together the pyramids. How can a people who can do the pyramids in Great Zimbabwe have no contribution to the world? And by the way, it is important that you understand that your forefathers built Great Zimbabwe. It is important that you understand that your forefathers built the pyramids. It gives you confidence. You say, I can write a book on control systems. I can be as good as these guys, but better on AI. Because when I was building the pyramids, the way it kept. And all these things about Socrates and Plato, go and read two books. One is called Stolen Legacy. The other one is called Black Athena. So, what does this book say? The summary is, also called Greek philosophy is actually coming from Black Egypt. All the stuff you give to Socrates and Plato and so on, great stuff, but the mother of that knowledge is the Black African. It's important that you understand that to give you confidence that I can do a business as good, if you're better than Elon Musk, than Bill Gates. We must have the confidence to challenge MIT on science. So very important issue about acknowledging and leveraging our indigenous knowledge systems. It will come up a lot in the next project. The first point you mentioned is very important about Tanganyika. If we're going to do well under AI, we must democratize it. Who owns AI? Who's creating the apps? How many women are involved in the crafting of AI apps? If we don't, the prejudice against women that's in society come into the apps. So the biases, the discrimination come into the apps. We must have more women creating apps in Silicon Valley, in London, in Harare. We must democratize AI by participating in the creation of the algorithms, in the creation of the AI systems. I said women, right? Black people, Africans, must participate in the crafting of the software. Right now, if you talk to Siri, Siri might not understand your Zulu name or your Shona name or the Bele name because it was crafted from Silicon Valley. The language and the intonation, the accent is from Silicon Valley. It's not from Tolocho or from Guyana or from Utiki. It is very important that somehow we democratize AI by participation in the crafting of the AI systems. By partnering, by doing it on our own. AI for Africa by Africans, not to the exclusion and in partnership with Silicon Valley. If we don't, the very same differences and biases we have in society will come into the programs. But more significantly, I did talk about the money, it's coming to my next book. This AI technology is contributing 7% of collective GDP, of global GDP every year. $7 trillion, collective global GDP is $113 trillion, AI alone is putting 7 trillion. We won't participate in 7 if we don't recognize to go to Silicon Valley to buy in America. For us to be getting a piece of the pie, we must participate. Generative AI alone, one type of AI is contributing $4 trillion a year. 4! Just to show how big this is. That's the German economy. The German economy is $4 trillion. So generative AI alone is equivalent to the GDP of Germany. This is why it's a revolution. Category 1, announcing generative AI is equivalent to the whole economy of Germany, or closer to home. Generative AI at $4 trillion is bigger than our collective GDP as Africans. What's our number? Generative number is $3.1 trillion. The actual is about $2.5 trillion. So what we need to AI technology is bigger than the entire African continent. So if we don't democratize AI, that $4 trillion will not be experienced in the global south, in Africa, South Africa. It's a very important subject. Democratization by ownership. Who owns Google? Who owns OpenAI? Who owns Microsoft? It's not your grandfather or your uncle or your sister, somebody else. We must also own. That's why we respect people like Mutambara who own businesses. We must see who own business. We must own AI companies. That's part of the democratization of AI. Now there's a big one, which I'm going to give you around democratization. You know, number one, we must adopt AI. We must use it. That's number one. But that's the easier part. Second part I was talking about just now, we must also create the AI. Create the system. That's two. There's a bigger one, bigger than those two. You know, when you say AI is run on chips, on hardware. It's not running AI. It's run on hardware. The hardware to run AI is very expensive. It's big business. And I'll give you a few numbers. You come and go, Google it. NVIDIA. That is the big company producing chips. They're called NPUs, CPUs, and GPUs. The hardware to power AI. There's one company that dominates. It's called NVIDIA. You know the market cap of NVIDIA as of 19 June 2024? $3.4 trillion. One little AI company that does the chips. Forget the AI algorithms. They don't do that. Chips. Just the chips. The hardware. The power of AI. $3.4 trillion on the 19th of June 2024. On that day, it became number one company in the world. Ahead of Microsoft, ahead of Apple. I say this to say, if we're going to be participating in the revolution, we must also play in our own little way in the hardware. Because $3.4 trillion for one company. Bigger than our collective GDP as Africans. Bigger than France, bigger than Brazil, bigger than Russia. NVIDIA, Google it. So number one, let us use AI. Number two, let us write programs and use AI. Number three, harder, but must be aspirational. Let us play in the hardware space. After all, we have the minerals, lithium. All these minerals that are used in, we have them. Can't we leverage that? Can't we leverage our scale? Why don't you partner with NVIDIA? You don't have to partner with NVIDIA. As the continent, as SADC. So I'm glad you raised this. It is very important that we democratize technology. We produce technology. With technology transfer. Otherwise, we just remain consumers, and poor consumers at that. We must, in addition to consuming technology, become producers of technology, producers of knowledge. Thank you for those comments on indigenous knowledge systems and on democratization of technology. Get another one? Related, you can go take yourself.
Thank you for imparting your knowledge and, of course, compiling it in a book for the wider public to now, pick your brain and your knowledge. I have a question as a student and someone of, the newer generation. What would your advice be, or does your book allow for, someone with no background in coding or AI to enter that space of, the next revolution?
Okay. Yeah. And by the way, I got some books here for those who want to. It's kind of expensive to go online, so I got them cheaper here through the publisher. You can, and also I've got political ones for those who are political. But I'm not talking politics, they're talking engineering, but I got political ones. This one is a bit on the tough end because it's an engineering book. Used in part 3, so part 2, part 3, part 4. So it's not very user-friendly to lawyers like you. But the next one is going to be much more digestible, which is artificial intelligence, economic driver for the global south. That one will be much more useful. In fact, there's a section called Applications of AI in the Legal Profession. AI and the law. Because think about it, everything requires the law. I mean, if I bring a driverless car into Letchworth right now, or into London, I can't use it without the laws. So you lawyers must understand technology and be able to legislate for technology. How do you legislate for something you don't know? Economists, business must plan for technology. How do you plan for something you don't understand? That's why I emphasize that as a lawyer, you must understand a bit of philosophy, a bit of economics, a bit of engineering, for you to be a good lawyer. As a business player, as an economist, you must understand a bit of the law, a bit of engineering for you to be effective in your area. So, for example, as you pursue your degree in law, be broad. Go to the debating society, talk about politics. Go to economics, learn a bit of economics. Go to engineering, do a bit of reading or coding if you can. Be broad. Yes, become a lawyer, but be a lawyer who's broad. It will serve you well as a lawyer. You'll be a better lawyer because of it. And since you are in university, that's the time to learn, because you've got all the time. And so don't just be single-minded on the law. Be broad. And spend more time. Actually, that's the story of my life. I was in high school, I was good at history, English, and everything, MPC. But I spent my time doing history. Mass chemistry physics was my subject. University, I was doing electrical engineering, but I was in the law school with Mutambara and Guto as our professors, and I was running the students' union as a student leader. So I was getting the breadth, both sides. And by the time I didn't know the way to the Renaissance man, but I was actually a Renaissance man before I knew what it meant. Because from high school, I was in history, I was in English, I was in mass chemistry physics. University, I was doing electrical engineering, but I was doing politics at the head of the students' union. At Oxford, I was doing robotics and mechatronics, but it was Oxford Union debating. We need to fix our British educational system. It's got a problem. It's focusing on exams and specialization. A-level, MPC. How do you do AIMS? That's math, physics and chemistry, without knowing how to balance the book, without understanding history. In America, unlike England, they do what we call liberal arts education. First, it's very general. If they MIT, they teach you about balancing a book, they teach you a bit of history, American history, a bit of the Constitution. So when you become an engineer who understands how to read a spreadsheet, how to read a balance statement. Yeah? We focus too much on specialization too early. and we were focusing on the degree. In America, I taught in America. In the English system where we are now, at Oxford, they say, okay, Professor, how do I get a first class? How do I get a master's? How do I get a PhD? In America, the student says to you, Professor, I'm working with you on this. How do I get a patent for my project? Professor, how can I commercialize my project and form a company? At an undergraduate level, they're thinking business, they're thinking entrepreneurship, they're thinking patents. We're thinking first class, thinking masters. So we need a bit of both, by the way. We need specialization, but we also need to understand education as a means to an end, not an end itself. Bill Gates was studying at Harvard, studying physics, and a good idea, and left and found Microsoft. He never came back. He's a dropout from Harvard, but he gives more money to Harvard than all the Harvard graduates put together. So who needs a Harvard degree? So when I saw him at Davos, I asked him, hey Bill, how dare you drop out of Harvard? If it was me, the entire village would stone me. Mutambara, how dare you get a chance to go to Oxford and you drop out? You are so shameful. He laughed. He said, no, it wasn't that bad. I spoke to my professors and they encouraged me to leave. He said, look, you've got an idea. It's time sensitive. If you don't go now, I'm going to go taking my parents. Please go and form your company. Go, Bill. Leave physics at Harvard, go. But if it doesn't work out, please come back. We'll work with you to get your degree. So there was no risk involved. That's what I told you. There was no risk involved. In Zimbabwe, if you withdraw, if you're discontinued, they never want to see you in the business of Zimbabwe. Go away, don't come back. You are useless. You drop out. Useless. So our education is very rigid. You either do it in 3 years or you get out. 4 years you get out. In America it's a credit system. You can do your degree in 10 years. You need 200 credits. So you have 200, you go away, come back, and you get 200, you graduate. So you can do your degree as a flexible system that allows entrepreneurs to do their thing. So Bill Gates never went back because he didn't need to. The project took off. But if there was a problem and the company didn't take off, they were going to take him back and work with him to get his degree. We need that kind of flexibility in the UK, in Zimbabwe, in South Africa, where we allow our #1 student in law to go away if they have a good idea. And if it doesn't work out, we take them back. Your #1 in chemistry, #1 student, if they have a good idea, encourage them to leave, to form that company. If it doesn't work out, take them back. So it's not risky. But our systems are not like that. If you leave, I don't want to see you again. You are a dropout. And by the way, don't just drop out without a good idea. So anyway, my message to you is you are at the university, you are very lucky. You have ChatGPT, you have Google, you know, you learn as much as possible. Get your law degree, no question about that, but learn about other things. We want an engineer who can define constitutionalism and constitutionality and the difference thereof. You know, I saw some lawyers being interviewed in Zimbabwe to become judges, and they didn't know the difference. What is the difference between constitutionalism and constitutionality? But I'm an engineer and I know that one, because I'm a Renaissance man. So you must become a Renaissance man who can define machine learning and so on and so forth. But you are very lucky. Some of these old mandalas are now technophobic. You know, young is better. You give a young person, give a 5-year-old a cell phone. Yeah. They'll figure out how it works without a manual. But if you give it to you, you get a hard time. The older you are, the harder you are to. I'll tell you myself, when I went to Oxford in 1991, I never used the ATM machine. I think we were just starting in Zimbabwe, we were not there, I don't know, but I never used it. So when I went to the ATM machine, it was NatWest. I was worried. It's just me and the machine. What if the machine choose for me? Oh, there's no weakness. I had a degree in electrical engineering, but I was grappling with the ATM machine. I was worried that I'm here in the dark with the machine. And the missionaries will give me my money. What if he shortchanged me? Technophobia. That is 1991. But moral of the story is that the older we get, sometimes we get worried about technology, we don't learn it fast. So you are very lucky to be in the university at this stage. I'll take the last question, comments, and then we can mix and mingle and chat. People can look at the books, and I'm sure there's some food in there. So in Shona, Ukama Igasha, that is what a chikav. For those who don't understand, relationships are consummated by some food. Okay, that's a very last thing. In the European sense, I didn't tell you there's going to be food. Why do you want food? I mean, in Africa, if you visit people, if you don't announce it, they offer you food. In fact, they would rather not eat if you visit. In this culture, what are you thinking of an appointment? I didn't even. Secondly, I have no food for you. You didn't tell me you're coming to eat. Culture is different, but in our culture, food is such a social good. People would rather starve and feed the visitors. That's different. And so we are going to practice it here in Nyaradzo. Ukama igasha. Knows that this one chikafu. Relationships are consummated by consumption of food. And we're going to deal with that. Okay, so let me have one or two more comments and we'll close it down. And then maybe we give one training an opportunity to say something. He's been quiet here. We're going to provoke him. He's brought us together, so he has one or two things to say. Yes, sir. Go on.
Oh, thank you. Thanks, Professor.
Yeah. It's okay, go on.
Okay. I follow so much on you as an individual. And most probably because I was at college almost the same time. Now, you took a step when you went to study robotics, and I would say it's like someone is seeing the future before it dawns on many people. And I followed when you went into the government of national unity, and probably at the conclusion of it, I was, there are people who would follow on you. Sometimes you don't know. I was hoping that probably you would transition to academia within the country and add value so much. Especially now we talk of artificial intelligence, and it's now commonly talked about. But these are some of the things that those who were living ahead of times, probably people like you, knew. So I expected that probably you would transition to academia. I know you then went to South Africa, Professor, and I see, I think, reading about the School of the Future. And now, looking at your background, which is both the political academia and the likes of people like the Vice President at Google, navigating through politics and academia, I would have thought you were going probably to come up with something. You should be able to navigate through politics because you have been there. So I thought you would still navigate and come up with something, like an institution we had, like was it industrial, which was being headed by Professor Chitsang. Yes. And take that lead in the field of artificial intelligence within the country.
Okay. Got you. Yeah. Thank you very much. A very important observation. But we're not thinking regional. We're not thinking continental. So yes, we must fix Zimbabwe, we must work in Zimbabwe, but we also make contribution at the SADC level, continental level. So I'm still impacting Zimbabwe through SADC. But as I described to you, if they can't even allow me to launch my little book, would they allow me to set up an institution? I mean, you know, it's not an excuse, but I'm just showing that sometimes our environments are not exactly as supportive. But point taken, we should do things in our country, and I'm going to do a lot in AI. Actually, just 2 days ago, we had a virtual meeting in the Australian Embassy, the Prime Secretary for Technology, and so we're together in virtual. We'll do that, but we must also realize that we need a regional trust, we need a continental trust. We need to fix our mindset of the leaders. Not that we should be allowed, but we should do things like I did in spite of the blockade, so we can do that. Now, as I conclude now, I want to just summarize 1 or 2 things that I've emphasized. Number 1, we must fix our problems. We must participate in the resolution of the challenges of our country, just as you are suggesting. But beyond that, let us make sure that we have scale. We cannot effectively implement AI in South Africa, as Nigeria, as Zimbabwe. We can do it as SADC. We can do it as ECOWAS. We can do it as the East African Community. We can do it as the African continent. A pan-African approach that speaks to the African diaspora, what is now called the global Africa. And the last point is that it can't be business as usual in the way we train ourselves, in the way we are trained. We need to become a Renaissance men and women. We need to be broad. But more importantly, we must make sure that we do AI at 3 levels. Use and adoption is number 1. The creation of AI and AI systems, number 2. And number 3, we must play in the space of the hardware that powers AI. But most importantly, I always end on this note because I don't want you to be confused by your success. Collective success is more important than individual success. We must care about whether Zimbabwe is doing well as a country. We must care about whether Africa is doing well as a continent. And I'll end with the story that I always do end with, which is my own story. When I go to Davos, when I go to MIT, and I speak, they're very impressed. Oh, we like what you're saying. Very wonderful, fascinating speech. Where are you from? Then of course I don't want to answer. I say I'm coming from MIT, I'm a product of McKinsey & Company, I'm a Rhodes Scholar, I've got a doctorate from Oxford. Yeah, that's fine, but which country? Which country are you from? Eventually I say, I'm from Zimbabwe. They're like, come on. Professor Mutambara, if you are that smart, how come there's cholera in Harare? Professor Mutambara, if you are so knowledgeable, how come there's poverty in Zimbabwe? How come Africa is bankrupt? So my rockstar status, my superstardom, is decapitated by the bankruptcy of my country, the poverty of my people. You will never be respected as a Zimbabwean until Zimbabwe is done well as a country. You will never be respected as an African until Africa is done well as a continent. That's my charge to you. And I head over to Bamatanani Guy and his team there to close out on the announcement. Thank you so very much.
Thank you, Professor. I think this is a conversation that we at Nyaradzo, we try to spread. starting first within the organization itself, in the country. And as you see, we are here now in Lechwell. It's part of us reaching out to Zimbabweans and being a platform for other Zimbabweans like yourselves to come into the United Kingdom and come to Nyaradzo House, which is a Zimbabwean entity, for Zimbabweans to come and interact with each other. So we'll take that message, and we have also learned today a lot about technology that we can use, first of all, in our households, to the organizations, to the way that we interact. And we are responsible as Zimbabweans. I know people don't like to quote our politicians, but I'll do it today. I hope the audience will allow me. So we are the people who are going to bring Zimbabwe, to bring Africa out of the doldrums. There is no way the West will be interested in making SADC a better region. What will be their benefit? There is no way they will develop systems to generate electricity for us. Why? You are the ones who are staying in the dark. So it is on ourselves as a people to look at solutions. And thank you, Professor, for preaching that word across the world. I know your last comment there that they then ask, people like us now with British passports, they say, okay, oh, you're British, but where are you actually from? And I said I'm British. I know that. But where are your parents from? Then in the end, we honor. They say, oh, but how is the electricity still now there? What's happening to the Caribbean? We built that dam 65 or whenever. But do you have electricity? Cholera now. So I think the onus again comes back to that message that until every Zimbabwean, every African is in a better place, can we be respected across the world? Without that, you can do all the tricks, gimmicks you want in the world. The bottom line is like, where are you from? And that will define you at Davos. Thank you, Professor, and we want to wish you luck as you spread the word in the other book launches you're having. And as for us, Nyaradzo, we are delighted that you chose to start here. And for those that are listening online, we encourage you to buy the book and to take that message that we are on and we are the masters of our own destiny. Thank you, Professor. We've got some food here, just some snacks for those that have got a minute, and you can still interact with the Professor. I know it's with a busy schedule. We've got the book as well here. Those who want to buy, you can buy online, but we've got a discounted price today for you. So thank you so much, and wish you well as you travel back to your destinations. Thank you. Food is over there.
Thank you so much, guys, for hosting us.
Thank
Makan ibu aku mana?